Hey guys, the last thing that we're going to cover in this module is comparing box and whisker plots. So let's go ahead and look at the first one. It says Mr. Athens and Mrs. Gilman gave the same test to their math classes. The scores of each class are shown below. So we have what's called a double box and whisker plot. So this represents the data set of scores for Mr. Athens' class, and this one down here represents a set of scores for Miss Gilman's class. So they didn't tell us how many students are in each class. So we don't know that information specifically or every single person's score, but we definitely can tell a lot from these two plots here. So let's go ahead and look at the questions that we have over here to the side. Number one says, what is the difference in the median score? Well, it looks like the median of Mr. Athens' class is going to be the higher one. That one's 80. And then the median of Miss Gilman's class is 75. So we are going to subtract. Let's get my pen ready here. Subtract those to find the difference. So we're subtracting 80 minus 75, which gives us 5. So we could make a statement and say something like, the median of Mr. Athens' scores is 5 points higher than Miss Gilman's scores. Okay, number 2, which class had the greater range of scores? Well, sometimes it's a little difficult to tell when you look at it visually exactly what the range might be, but this one, it is pretty obvious that Mr. Athens' class definitely has a larger range of scores because his scores go all the way from 45 to 100, and then there's a smaller range in Miss Gilman's class. So Mr. Athens has the greater range of scores. The scores in his class are more spread out. Okay, number 3 says, which class do you feel did better overall? Justify your answer. Now, going back to number 1, we did look at the medians already, and we said that Mr. Athens' class has a higher median. Now, if we only knew the median and that was the only value we had to go on, we would have to say overall that Mr. Athens' class did better because his median score was 80 and her class was 75. But we have a lot more information to look at based on the box and whisker plots here. So if we look at, let's say, for example, the score 60. Well, that was the lowest score in Miss Gilman's class. Everybody in Miss Gilman's class scored a 60 or higher. Okay, but if we look at Mr. Athens' class, we have 25% or 1/4 of his class, which is a pretty decent group of his class, that scored below a 60. So despite the fact that he has a higher median score, I would argue that overall Miss Gilman's students performed better because all of her students scored at least a 60. So coming over here to our justification, I said Miss Gilman's class did better overall, even though her class had a lower median. 75% of her students scored a 70 or higher. Okay, 25% of Mr. Athens students scored below a 60, which we just discussed a second ago, and no one in Mrs. Gilman's class scored below a 60. So you have to be careful about looking at just one specific data point to make a generalization about a data set. You have to look at the whole picture and the whole spread of the data to decide exactly what the data is telling us. Okay, looking at the next example, it says Mr. Whitman gave a test to his 32 math students. He felt the results were low, so he retested them 1 week later. The results of the original and retake test are shown below. So this first plot represents the original test grades, and then these are the retest grades. Okay, number 1 says, what is the difference in the median grade? So it looks like the median on the retest was an 80. And the median on the original test was a 60. So the difference in those is going to be 20 points. Okay, number 2, what percent of students scored at least a 60 on the original test and what percent scored at least a 60 on the retake? So let's look at the original test first. What percent scored at least a 60? Well, it looks like only half of the class, or 50%, because remember each quartile is 25%. Oh, trying to write that in. And we got some crazy stuff going on here. Okay, let's see if we can erase some of that. Okay, so as we were saying just a second ago, 50% scored at least a 60 on the original test. So on the first test, only half of the class scored above a 60. Now let's look at the retake. Well, here's 60 on the retake, and it looks like that the entire class, or 100%, scored above a 60. All right, number 3, if students need a 65 in order to pass the test, how many more students passed the retake? Okay. If we look at 65 right here on the original test, okay, it looks like 25% of the students, okay, made a 65 or higher on the first test. So we want to find 25% of 32 students. So we're going to do 0.25 times 32, and that gives us 8. So only 8 students passed the test on the first test. Okay, now let's look at the retake. So on the retake, 65 or higher. Okay, here's 65. So it looks like we have 1, 2, 3 quartiles, or 3/4 of the data of the students that scored at least a 65. So that's 75% of them. So we need to find 75% of 32 students, and that's going to give us 24. So those are the two numbers that we need to answer the question. So if it says how many more students pass the retake, that tells us that we need to subtract those two answers. So if we subtract 24 minus 8, we get 16. So 16 more students passed on the retake. Okay, so that's it for comparing box and whisker plots. So you can go back, pause, take notes, redo anything that you might need to, email your teacher if you have any questions, and then you'll have some independent practice coming up in the next piece of the module. Hope everybody's having a good day. Thanks, guys.